Okay, now we're going to move over to waveforms. So as we saw with the simulator that I just showed, there was at the bottom, we used those flags to get out a diagram of the timing. The timing, we're generally just going to call it a waveform. So a waveform is going to be the visual representation of our circuit using the input and the output. And we really want to show it as a change due to the flow of our input. So let's just kind of start off a little simple. Let's start off with a NOT gate. And let's say this NOT gate, the input is X, and we have an output of Z. And we want to say, okay, let's show how Z changes if the X was given as a stream of input 0, a 1, a 1, a 0, 0, a 1. So what do all of these items mean? Is let's set a time for each input. So let's just say each input here is 10 nanoseconds. Okay, so what we want to say is let's just going to create a diagram. This diagram is going to have X on it, and it's going to have Z. And we're going to plot out items in increments of 10 nanoseconds. So 10, 20, 30, 40, 50, 60, 70, 80. So we can plan out all of these different amounts of times. Okay, I said I wanted the inputs to be 0, 1, 1, 0, 0, 1. Now I'm going to put little dot lines on the timing because this is going to help me know how far to draw out my X. Okay, so I said I wanted a 0. So starting at time 0 to 10, I'm going to have that the X is a 0. Then from 1 to 20, we want it to be a 1. And we're going to draw little transitions here. So we're going to fill in that dotted line. And then from 20 to 30, I also wanted it to be a 1. Then I wanted it to be a 0. So we'll drop the drop. We wanted it to be a 0. And then we wanted it to be a 1. And let's just say it stays 1 the rest of the time. Now, this is a diagram that we have of the changing of the input. When you start drawing these diagrams out, you can do all the input all at once because the input is something you're supplying, and then you're going to see what the outcome of it is. And remember, we just have this NOT gate that we're doing. Now, the first thing I'm going to talk about is a functional diagram. Now, this one is not discussed in the textbook. The textbook talks about the second type of diagram, which we'll do in a separate video. But functional diagram, here all we're concerned about is the logic. No delays of gates. So we're not going to see how long in real life this is going to take. All right, so let's just say here, I'm going to do this Z. I'm going to do it in a different color so it pops out that this is the output. And we know this is X bar. All right, so I'm going to look at Z here. I'm going to try to figure out, okay, what is the output of Z? Well, if X was a 0, we expect X bar to be a 1. And then the times it's 1, we expect it to be a 0. We expect it to become a 1. And then we're going to expect it to be a 0. So we're just kind of like following the flow of this electrons as we go through the gates to generate what our output would be. Okay, so let's just do something a little bit larger in scale. Let's say that we have that I have two AND gates, and then they're going to get an OR gate on the outside. So let's call that Z. Let's have the input be an A going through a NOT gate, and then we take that A to the other item, and then I'll have a B and I'll have a C. Now, I'm going to also define little intermediate spots. Let's call this X and Y, because then I can kind of make it a little bit easier for me to write out my circuit. So we know that X here is going to be A bar B. We know Y is going to be A C. And then we know our Z will be X or Y, just to make it a little bit easier for us to try to solve this. Okay, so let's make our timing diagram. I need an A, I need a B, I need a C. Then I'm going to need an, let's go ahead and throw in A bar as well. That way we can show everything being on this diagram. A bar, X, Y, and a Z. Now I'm going to have to scroll down quite a bit because of the way I'm drawing this out. You know, when you do it on your paper, you should have more than enough room. So let's do everything at 10 again. All right, so we have those items. Let me put some dotted lines to help me draw out my initial inputs. All right, so let's put some input in for A and a B and a C. All right, so let's have A be 0 for 2 time periods. Let's have it go high for 3, low, high, low, low, and then we'll end at a high. Let's have B be low, high, high, go low, go high, go low throughout. And then let's have C be low, high, high, low, 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 high, 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 low. All right, so we have these items here. All right, so let's follow and let's do the A. So let's do this one. So let's do black as our inputs, and then let's do A bar in like a different color here so we can see what's going to happen to it. So we expect A bar to follow the opposite of A. So we can say, okay, well, A was a 0, A bar is a 1. Then we have some zeros. We go high, low, high, high, and low. All right, then let's focus on X. So X is, let's go back to our circuit here. It said it was A bar and a B. All right, so which ones are we looking at? I'm going to highlight some stuff and then later I'll come back and erase the highlights. So I'm looking at this B item and then I'm looking at this A bar item. All right, so I want to use those as if there was an AND gate. So I have a 0 and a 1. A 0 and a 1 knotted is a 0. And then I'm going to have a 1 and a 1. So that's a 1. And then I'm going to have a 1 and a 0. So we drop back down. 0, 0, 0, 0, 0, 1. And then we have 1, 0. Then we have 1, 1. So we go back high. And then we have a 0 and a 1. So that's low. And then we have 0 and a 0. So that goes low. So that's the way our X is going to be acting. Now let me erase this highlight. And then let's talk about Y. So let's have Y be this blue color here. And Y, let's go back. That was A and a C. All right, so let's highlight our A and a C so that we can follow along what it is we're doing here. So we have 0 ended with 0, so that's 0, 0 with a 0, 0, 1 and a 1, so that's high. 1 and a 1, high. 1 and a 0, so that goes down to low. 0 and a 0, that's low. 1 and a 1, so that's high. 0 and a 1, so that's low. 0 and a 1 is low. And then 1 and a 0, that's also low. So that's how we're going to follow out our functional diagram here. And then we end at z, and let's do z as being orange here, and our z is x or the y. So now we're looking at the intermediate outputs, the in-between spots. All right, so we have 0 and a 0, so that's 0. A 1 and a 0, well, that's OR, so that's a 1. A 0 and a 1, 0 or 1, 0 or 0, 0 or 0, 0 or a 1, 1 or a 0, then 0 or the zeros. And that gives an idea of how our circuit is flowing through. And how will we use this is, as we start designing our circuits, we want to either have that we do these functional diagrams by hand, or the simulator is going to generate it for us. And with the simulator generating these items, we can go back and we can examine and make sure our output is correct. So you can kind of think of this as like debugging, like if we were writing programming code. Now, the important item here is that functional diagrams are only showing did the final result come out to be true. We're not looking at any type of real world situation. We're going to talk about the real world situation in the next video, where we move this into a timing diagram.